derive the 6 trigonometric ratios. So to clearly visualize the 6 trigonometric functions, so let us consider the right triangle given below. So assume that this is a right triangle. So this will be the angle, the central angle here. Then the opposite of the central angle will be the opposite side or equal to y. Then the opposite of the angle 90 degree will be the hypotenuse. You can assume here this will be our r. Then the side opposite of this one is the adjacent side or x. So now we are now ready to derive the 6 trigonometric functions starting from the basic trigonometric function, the sine, cos, and the tan. So it has a acronym for us to easily remember the formula. So SOHCAHTOA stands for S will be the sine theta. Then O stands for the opposite over hypotenuse. So sine theta, always remember, is opposite over hypotenuse or is equal to, using the variable, y over r. The next, cos theta is equal to adjacent over hypotenuse. So adjacent x over r. Then TOA starts with tangent theta is equal to opposite over adjacent. So y over x. So now the next is the reciprocal function starting from cosecant theta. So that's reciprocal of 1 over sine theta. So 1 over sine theta is hypotenuse over opposite. So hypotenuse over opposite. The next is secant theta. Its reciprocal function is 1 over cos theta. It's also equal to hypotenuse over adjacent. Then cotangent theta, reciprocal for that is 1 over tangent theta or is equal to adjacent over opposite or is equal to cos theta over sine theta. So now we're now ready to solve the second example for the 6 trigonometric ratios of the given triangle below. So if this is the right triangle given in a 30, 60, 90 degree angle, so the opposite of the central angle measures or has a length of 5. Then opposite of 90 degree is 13, the hypotenuse. Then the adjacent sides will be 12. So now find the 6 trigonometric ratios starting from sine theta. So sine theta is equal to, using the formula, opposite over hypotenuse. So the opposite sides of the central angle theta is 5, right? Over the hypotenuse, which is 13. So 5 over 13. Next is cos theta. Cos theta is adjacent over hypotenuse. So our adjacent side here, the x is 12 over 13. Then next is tangent theta is equal to opposite over adjacent or sine theta over cos or y over x is equal to 5 over 12. Next is the reciprocal function starting from cot theta is equal to adjacent over opposite. So our adjacent side here is 12 over 5, right? Yes. Next is secant theta. Reciprocal is equal to hypotenuse over adjacent is equal to hypotenuse is 13 over the adjacent, which is 12. Next, the last, cosecant theta is equal to hypotenuse over opposite is equal to 13 over 5. So here are the 6 trigonometric ratios of the given triangle.